Hello, everyone. Good evening and welcome to our next Zurich Azure user group meetup session containing the another cool session about our AKS series. Today, now we have as a speaker Marc Merzinger, who will tell something about his experience in a project we made a migration from Azure App Service to AKS. That's a topic for today. Just a few words again about who we are in that meetup group. So we have the hosts Manu, which already said hello to you. We also have Carl in the group and myself speaking at the moment. Just a few review and outlook on the series in the area of AKS we made so far and we plan in the future. So we had this introduction by Jonas Felix and the introduction to AKS itself by me. You can find all slide decks and sessions in the information in our meetup group. So the recording is available there and the slides are available. And today, as introduced, the migration from the app service by Marc Merzinger. The next session, number 4, would be by Nike Meisenzahl. He will give us some more detailed insight about integration topics from other Azure services to AKS. In the 5th session, Muhammad Nofal from Microsoft will tell us something about specific and advanced topics regarding security in AKS. And last but not least, we have Radoslav Gatev from Bulgaria. He will tell us in the session something about how Dapper and distributed applications together with AKS work. Okay, so I think enough from us and introduction. So we can jump over to the content of the evening of the session. And I will hand over to Marc. I will put him into, where's my mouse? Into the session so you can see him. He can say hello. And then, Marc, I would say the stage is yours. And let's have a good session.
Okay. Thank you, Thomas and Manu. Welcome from my side as well to today's session about migration from Azure App Service to AKS. Few words about myself. I'm Marc. I'm a senior software engineer from T&M. I'm part of the cloud engineering team, and although I'm a software engineer, I'm mainly involved around automation and cloud topics. So from the design of cloud environments on Azure or GCP to the automation of it with Terraform or ARM, and of course the complete DevOps part from CI/CD. In my free time, I maintain my own blog, cloudjourney.io, and there I try to cover all the cloud native stuff that's out there, which is quite interesting. Okay, that's it about myself. Today, as I said, I will talk about the migration from App Service to AKS. First, I will give you a short introduction about the application and the runtime environment that we had previously. Then how we did the whole migration to AKS, a few challenges during the migration, and then in the end, a few pros and cons about the migration. Nothing in IT is for free. And then a few learnings of things that I would differently in the next time, and a few tips for you if you would have to do a similar scenario. Okay, so the application. On the right-hand side, you can see a generalized overview of how the application is designed. So currently it's still based on .NET Core 3.1 in the backend, which will be migrated soon. So in the end, we have a software load balancer as the single entry point. We are using a DDD architectural flavor for the application. So we have bounded contexts, which represent our microservices. And as we use CQRS and event sourcing, we split such a microservice into a command and a query side, as well as a projection handler. That is why we have like the DB for the command API, and then we project the read side via the projection handler. Of course, we have a front end, which is a React-based application. As of now, we have around 7 executables, which make up the application, as well as one for initialization jobs, which we need for new environments or some cleanup tasks that are executed every day or every week. And this is the previous runtime environment. So back then, when we started to develop the application, it was rather small, and there was no need for an AKS. And so we started small with an app service. As you can see, we just mapped all the executables to app service apps, which then were running on one app service plan. So we could be quite cost efficient there. We used Azure Functions to run our jobs in the end, time-based triggers, and so on. And from the storage side, we use Cosmos DB as our command storage. Then, of course, a service bus to have the messaging between the microservices, SQL Server for the read side, and a storage account for uploads from the users. For the secrets, we used Key Vault, which is quite simple. I think it's the standard service on Azure anyway for secrets, and for ops, let's say the standard Azure tools that are available: Azure Monitor, Log Analytics, and so on. From the technical side, we did externalize all the state. So all the command API protection handler, they're completely stateless. We can stop them at any time because everything is externalized. And that was the starting point where we had to grow. So this was like the beginning of the application, and then we needed to grow, and we had to do isolation topics. For example, the projection handler is nothing that listens for web requests, so it shouldn't be exposed anyway to the internet, like the command API as well, because we have the software load balancer in front of it. And so we thought about what should we do with this environment, and then we talked a little bit about it and said, well, AKS would be a good replacement. And as I said, we needed to be cost efficient, especially in the beginning. And one way to solve the whole isolation part, for example, was to use isolated instances from app service, so the isolated SKU. But back then, it was quite expensive to use it because there were like the space stamp fee and so on. With version 2, it got a bit better, but it still would be quite expensive. And then, of course, each application resides somehow under its own domain, but we don't really need that in a whole. And of course, with a standard app service is exposed to the internet, which is something that we don't want to have. And those were a few of the reasons why we said, okay, we should go to an AKS. And of course, we get more flexibility out of an AKS compared to an app service, but we also have to manage a bit more, but it's something that I will cover later. Okay, so that was more or less the decision to say, okay, we need to go to a different service, so AKS. And previously the application was not containerized at all. We just packaged it and deployed it to app service. So we needed to have a migration approach. The migration approach was quite simple, as we could do the migration during development time. So we hadn't to do like a switch from one system to the other without interruption. That was not the case. So we could do that during development. We said, okay, first of all, we need to containerize all our binaries or executables. And we decided to use Helm charts to deploy them. And both Docker files and Helm charts is something that you can generate with Visual Studio. I will say a bit more about this later. We used Azure DevOps for the whole automation part. So before the migration, everything was automated with Azure DevOps CI/CD pipelines, and we said we will continue with it. We will just extend them. The infrastructure was deployed with ARM, or is still deployed with ARM, and so we just needed to extend those templates to cover all the AKS resources. And then there was like a whole team developing the solution, and we needed to get the know-how into the team, so around AKS and all the stuff that it's needed to maintain it. And so we said, okay, we will take a bit of the capacity from 2 members of the team that set up the infrastructure previously, and I will try to give them as much knowledge as possible and help them then to manage it. And of course, the rest of the team should concentrate on the features, because every project needs to deliver features. Okay, so from the planned runtime environment. The overview, let's say, is quite simple. We just replaced the whole compute layer, but in detail, it's not as easy as it looks. So we can, of course, remove all the app service specifics and move to Kubernetes, which would be then the primary compute platform. But Kubernetes is by default quite empty. So there is no default ingress implementation, for example, and you have to manage the nodes on your own, which is something that you don't have to do with app service. So we needed solutions for it. And so we decided to use the Nginx as an ingress controller, which is inside the cluster. We're not using application gateway. The nodes need to be rebooted on a certain time, depending if there are security patches that require a reboot. We just use QRD for this topic. Then that was a convenience feature, I would say, from app service, which is just the SSL certificate that you get out of the box. And we wanted to have this behavior as well. And so we use Cert Manager in combination with Let's Encrypt to automate this inside the project. But from the overall patterns, we will still rely on the persistent services. So still everything inside Cosmos DB, SQL Server, and so on. The AKS is deployed with the Azure CNI, so it runs inside a virtual network, and all the pods get IPs from this network. Sorry. And so it's, let's say, from the network, this is 1 degree or one kind of isolation. And we said, okay, we need to have some kind of access from our application to Key Vault, which is still the secret management solution. So we use Azure Managed Identities for it, and pod identity to map a service from Kubernetes to Key Vault. And that's how we said, well, we will plan this environment. So inside AKS, we will separate each component from another with namespaces that we can do, like namespace isolation from network policies, for example, and just from the deployments, which makes it better from the overall perspective. Throwing everything into one namespace is not a good idea. And with this plan, we started to extend our pipelines. So as I said, we were using Azure DevOps for the CI and the CD part. And I just simplified the CI. CI is not more than a few checks for the infrastructure part. The CD is then just the deployment of all of the ARM templates. Because in the beginning of the migration, we said, okay, although we don't need to have like a swap between the environments for the users, we want to have the environment still stable for all the developers, that they can test stuff. And so we really deployed app service and AKS side by side. And we needed to extend the pipelines to cover all the, we call it cluster components or basic cluster components like Nginx or QRD and Cert Manager and so on. So this is a pipeline that deploys all those templates to Azure. So the next step after we have the infrastructure ready is to containerize our applications. So as I said, our applications were running natively on app service. We needed to Dockerize or containerize them. And Visual Studio provides a quite handy feature to generate Docker files for .NET or .NET Core applications. And it can see the .NET Core version, and it then can use the right base image for it. And it also references all the needed projects from this executable that you want to Dockerize or containerize. The good thing is it provides multi-stage Docker files. So you have a build stage, which contains all the SDK tools and the debugging stuff that you need to build it, and a final stage, or you can call it runtime stage, which is then the final image, which is just ASP.NET Core runtime, including the application. And this is a quite easy task. It's just a few clicks, and then you're ready for development with containers. If you're using one, if you're using multiple, then it's a bit more. And of course, you can deploy it then. But it has some downsides. First, it uses Debian, like the Buster Slim images for the release stage as well as for the build stage. The good thing is it's a slim image, but still it contains a lot of stuff, and especially also vulnerabilities of tools that we do not even need. And this is something we verified with Trivi as the scanning solution. And we said, well, we need to change it. The other problem with this approach is that the projects that are used by this application or this executable are referenced statically. So if you change project references afterwards, you would need to regenerate this Docker file. So we had to change it a little bit to be agnostic over the project references, so we don't have to generate it over and over again. And I will say later a bit more about the base image topic. But that was it more or less to what we needed to do to containerize it. At this stage, we said we will containerize it and continue to develop without containers locally, because we would need to create a Docker Compose for it. That is something we do in other projects, but in this project we continued to do it with, let's say, the native Visual Studio multiple startup projects approach. Okay. After we had our application containerized, we needed to generate Helm charts, which is again quite simply done with Visual Studio. It's basically a Helm init or Helm create. I don't know exactly which it is, but it generates a standard Helm chart with a predefined name, and you have all the templates that you need, a deployment, ingress service, and so on, which is quite handy, especially if you want to go forward in a fast way. But as soon as we deployed it, we've seen, like, back then when you generated Docker file, it didn't even care about the user, so it was running as root, and the Helm chart didn't change anything about it. And so we had a weak security posture, I would name it, although I'm not a security guy. But there was no rootless, no read-only root file system. It contained all the standard capabilities from the default runtime. And so we said, okay, we need to change this a bit. And then we said, okay, we will use checkoff to check, like, for a PR, or then for the CI part, if we match certain policies. And of course, this Helm init just provides the standard resources. For example, a horizontal pod autoscaler, something that we needed to add back then. I think now it already contains it, but other resources like a pod disruption budget and so on, something that we needed to add on our own. And with that, we could go on and automate it. Well, this first part was just stuff inside the IDE, and then we could check it in. So now we needed to extend our CI setup. In this project, we were using a single Git repo for backend, and one for the front end, and one for the infrastructure. And this one, or this slide, shows the backend. And so we have two CI pipelines that are triggered either by a PR or by a push. From the container side, we do standard build, test, release. This is all done inside the container. Just for the sake of simplicity, I wrote .NET because in the end it's a .NET build. Then we do a Trivi scan inside the pipeline. We use test results for it as well. And we fail the pipeline if it's higher or critical vulnerability inside the image. And if it's a release build, then of course we publish it or push it to the Azure Container Registry. For the chart pipeline, it does basically the same. We do a scan, we package it, we publish it, we do a lint, and then we can use it from the Azure Container Registry, which allows us to store Helm charts as well. I think there is still no way to view it in the UI, but it supports this feature. And this is how we manage to build our artifacts and push it to our registry. I said that we use Privy to scan the images and to kill the pipeline when there is a high or critical vulnerability. I think there are multiple approaches to it. You can also say we just want to be notified, but we want to really know if there is something during build time, we will fix it first. We had this case once, but then you can just do the fix and go on. From the scanning perspective, we do this during the build time, but also we have the Azure Container Registry with the scanning feature. So there the images are regularly rescanned. Okay, so from the CD part, it's basically the same. We have our artifacts from the container CI and the chart CI. Both can then trigger the deployment stage. I've just visualized the dev stage, which is basically a bunch of Helm upgrades. We use some variables from the Azure DevOps variable library, depending on the stage, but it's basically nothing more than a few Helm upgrades. We use wait or the -- wait flag to check if the deployment comes up as expected. We had sometimes some issues where like the jobs were executing and like I messed up with something with the network policies, and then the jobs couldn't execute properly, and then the pipeline failed. And so we could like fix it and then run it again, and then it was yeah working as expected. The same mechanism is used for the front end, so it works kind of the same. As of now, the release pipelines are really release pipelines on Azure DevOps, like those UI-based pipelines, but we started to move away from them. The CI is already completely in YAML, and the CD part is partially as YAML. Some of them are still with the UI release pipelines built. Okay, so this was all the migration steps that we did to get our application on Kubernetes. But how did we do that with the knowledge? So when we had to do this migration, the team was had around 6 members, 1 PO, 1 Scrum Master, and 4 devs. There was an equal distribution around front end and architecture to the back end. And so we said, okay, still the team needs to concentrate around features. I should bring in the knowledge and kickstart the migration with the 2 colleagues that did the previous setup. And so we planned around 4 weeks for it. Just from the overall time perspective, we used, I think, around 10 days to do all the stuff. And so my role was to do like the heavy lifting to build the design and to build the pipelines. And then I could shift over a few of the tasks to my colleagues, and they could build the knowledge that they needed to continuously maintain and enhance the platform. And I think this approach was quite good. They could continue after I left the project and implemented other features. And I think roughly once a month we talk about other topics. From time to time there are new requirements that we need to solve. Some of them, of course, we need to solve with infrastructure. And that was the overall process that we used to migrate the project without much influence on the velocity from the feature side. Okay, now I want to talk a little bit about a few topics around how we solved certain requirements or problems in this environment. So when we were using app service, we pushed all the logs inside log analytics, and well, of course, we said we will continue to do so. We don't want to add a lot of complexity inside the cluster, so no internal state inside it. And so we said, okay, we need log analytics. Luckily, there is an integration from AKS. You can just enable it, and then there is a log analytics agent deployed inside the cluster, which runs on all the cluster nodes, and it forwards all the logs from inside the cluster. For example, from a namespace where a pod writes in standard out, it's directly pushed to log analytics. You can tweak it a little bit. We did some exclusions, but overall, that's how we push the logs from the cluster to log analytics, and then we can query them as all other logs. I think this integration is very easy to use, and I would recommend it before going into more details and saying, okay, I will want to build my own Elk stack inside AKS. If there is no special need for it, log analytics is a very simple solution. There is one takeaway of this approach regarding audit logs. We collect all the logs, especially also the audit logs, but there is one differentiation between just the write audit logs and the read audit logs. If you use just the write audit logs, then you have, it depends on what runs inside the cluster, but you can generate easily more than 1 gigabyte of logs per day. But as soon as you extend it to read logs, then it's way, way more, because all the components inside Kubernetes, they generate tons of logs. And as soon as you activate it, we ended up like with easily 7 gigabytes per day, just with an idle cluster and our standard components. So be aware that you need to find out if you really need all the read logs or if you can stick to the write logs. And in the end, log analytics stores the logs. We can then generate alerts from it to the team, and the team uses some dashboards to observe what is happening from the logs view inside the clusters. Beside AKS, of course, all the other Azure services put their logs into log analytics as well, like the audit logs from the subscription, the diagnostic settings from all the other services. Everything is stored inside log analytics. Okay, so as I said, during the CI/CD part, we changed our pipelines and started to deploy everything with Helm charts. And soon we figured out that there might be some inconsistencies between environments sometimes. So we really don't use kubectl a lot, but sometimes we needed to check something on dev. Then we changed it, and then there was some inconsistency. And we said, okay, we need to change that, that it's more consistent over all environments. And luckily, there's a feature. And so we use Azure Policy. Azure Policy provides a plugin for AKS. It's an add-on that you can just enable. It deploys then a policy add-on controller inside the cluster. For those who don't know how it works, it's basically just a wrapper around Gatekeeper and OPA, which allows us to translate like Azure policy definitions with or push them inside the cluster. And so we used the standard baseline initiative, which is pre-provided by Azure, that allows, for example, or denies privileged containers or CapNet sys capabilities on the containers. So there's a good baseline that we can use for the whole cluster. Of course, we need some exclusions. For example, a QRD needs to be privileged to be able to restart the nodes, but those are exceptions. Overall, we can keep the whole application against the standard baseline initiative, and soon we will migrate to even stricter initiative. There is another one that you can use for this purpose. Of course, if you need to have more fine-grained control, you can define your own policies. Overall, I have to say this is a very, very handy feature. We can see inside the security center of Azure how our cluster is doing, if there is something inconsistent, which violates our policies. Of course, we can run them in deny or just observe mode. Most of them are in deny. And so, yeah, we can see if something that is just observed, if it goes out of sync, and then we can change it. So yeah, it's a quite handy feature. Okay, the next topic is resource isolation. So this was one of the reasons why we wanted to migrate to AKS, is that we can remove services from exposure to the internet or to other services because it's not really needed. And so we said, okay, our central point of entry is the ingress controller inside the cluster. So this one gets a public IP address that is listening to the internet. And the ingress controller is just allowed to talk to certain services inside the app namespace so that other components are not affected from it. And the app is the only one that is, for example, allowed to talk to external services. We use VNet integration for most of these services just because it's more cost effective than using private endpoints. Sometimes you need to have a bigger SKU to do even VNet integration. For example, service bus is such a example. It gets quite expensive if you want to do that. And so we mainly rely on VNet integration. The isolation part is quite easy to do inside AKS. As we use the Azure CNI, we have layer 4 network policies, which are like IP port combinations. I would say it's quite restricted. I think other approaches could be easier to use. For example, if you use Cilium, then you could do network policies based on domains, which makes the stuff a bit easier. But we did it with layer 4 network policies. And that is how we can control traffic from outside the cluster, inside the cluster, and what is going outside again. Okay. The last point about some topics that we faced during the migration was the certificate management. As I said, app service does it in a really simple way for us. And so we wanted to have it as well. So I think the go-to solution is Cert Manager. It's a project that automates the certificate management. It can do much more than we are using, but for our case, we don't need more. So in the end, we have a Cert Manager installation, which listens on our ingress specifications. Is there a new ingress specification, for example, for api.example.com? It requests a certificate with the HTTP 01 ACME challenge against Let's Encrypt. There's a bit more magic going on in the background, but this is the high-level flow that it uses. And then it stores the secret inside the application namespace, or like in the secret that is referenced by the ingress resource, and then in Nginx can use it as the ingress or as the TLS termination certificate. And that's how we achieve certificate automation. I have to say it's very smooth. It requires almost no effort to deploy and to maintain. The only problem that we faced was that during the upgrade phase of Cert Manager, we stumbled into one issue where we didn't completely upgrade the CRDs. Then we had the problem with Cert Manager starting, but it's not a critical component. So as long as your certificates are not expiring in a minute, you can change or take it offline, update it, whatever you need to do. With a standard, I think the certificates are valid 90 days and they are refreshed after 60 days. So this is a very good tool for this use case. In our project, we use 2 domains, like example.com, and then we have one for production and one for dev and test. And so we never hit the issue that Let's Encrypt did throttling on us, because we are just requesting 4 certificates for dev and test and 2 for prod, because we have the front end and the API exposed to our customers and the users. So depending if they're using the UI or not. And that's how we automated all the certificate management in this environment. Okay, now I will talk about a few challenges that we faced during the migration. The first challenge, and this was just, let's say, a problem in the beginning, was efficient resource usage. So when we were using app service plans, or one app service plan, it was quite simple to host all those applications on one plan. With AKS, we introduced quite a overhead overall. So as soon as you deploy AKS, it's almost empty, but there is like the DNS. If you enable log analytics, of course, there's the log analytics agent running on the nodes. So they require some resources. And then, as we said, we use a in-cluster ingress controller. We had even more components requiring CPU. I mean, the alternative would be to externalize them, but yeah, then it would be just Nginx that falls away. But still, we had this overhead inside the cluster that we needed to deal with. And at this time, we needed to keep development integration environments as small as possible from the cost side. And so we had dedicated usage or resource request and limits overrides for those environments. And we could limit the cluster scaler to 2 nodes. So sometimes we would have extended this those nodes because we just had more requests. So in the long run, we changed it back to have 1 resource request and limit set overall. But for this period of time, we could solve the problem and just keep stuff low without having to do much in it. Then I mentioned it previously, the challenge about base image vulnerabilities. So the standard base image that you get is the Buster Slim image. And we said it's too big for our environment and we don't need all the tools that's inside this image. And of course, the vulnerabilities that you get included is something that we don't need. And so we said, okay, there is an alternative. We can use Alpine images from Microsoft, and tada, we had 0 vulnerabilities, but yeah, we broke the application. This is something we couldn't notice during build time because in the end, Alpine has no cultures, which is kind of a no-brainer as soon as you know it. But yeah, we were using cultures under the hood. We could build the application, we could deploy it, and as soon as we used a specific feature, it just broke. But this was quite easily to figure out. We just needed to modify the Docker file and install the cultures, and that was the solution more or less on it. If you want to read more about this, there is a good blog post that I referenced at the bottom of this page. We had one thought about using distroless images, but back then they were still not officially supported from Google or inside the Google repository, and as of now they are not even there anymore because I think there is no consensus on how those distroless images should look like, and so we still rely on the Microsoft maintained Alpine images as our base. And then another challenge, the read-only root file system. So you can enable the read-only root file system on your pod, which is basically if the application tries to write on a file, it's denied because it's read-only. And our application was standard web applications. There was nothing especially special tied to the OS. So we thought, okay, there should be no dependency. And so we enabled it, we could deploy it, it was working fine. But then we figured out, oh, file uploads are broken. And then we figured out that .NET Core uses under the hood that /tmp directory for buffering purposes. I mean, there's an easy solution for it. We just used mtdirs, like those are ephemeral volumes that are tied to the lifetime of a pod. And so we can mount this temp directory. This is then writable for the application. And that was the solution. Overall, we said we will use the standard storage that is mounted into the node. So it's a disk ephemeral volume and not an in-memory volume, because we have the SSDs on those nodes, and we want to save a little bit of the memory that we have available. Okay, the last challenge that we faced is a growing demand for resources, how I would call it. As I said, AKS comes with some basic services already pre-installed. DNS, CNI doesn't use a lot of memory and CPU, but it uses some of it. And so at the beginning, we need to guess where we will land from the sizing. And so we started with a 2 CPU and 8 gigabytes of RAM per node in the beginning. And with the time, we added more features, like cert manager. We have a Falco inside the cluster, a QRD, pod identity. All those things need memory and CPU as well. Especially most of them are daemon sets, so they run on each node. And so the available memory and CPU from this node gets smaller and smaller. Especially with 2 CPUs and 8 gigabytes of RAM, it gets quite small very soon. Especially Nginx that we needed to scale after we did some load tests. This needed even more resources, and so we needed to find a solution there. On the other hand, tools that became necessary over time. So initially, we didn't plan for Azure Defender for Kubernetes, how it was named back then, because it didn't support virtual machine scale sets that we use in this setup. But it was December where they announced Azure Defender for containers, and now we can use it inside of our cluster, especially with the combination image scanning on ACR and the Defender functionality inside Kubernetes and the Azure Policy plugin. And this is everything just for keep your environment running. But we haven't talked about the application, which requires resources as well. And that was then one of the reasons why we said, okay, we need to have bigger base nodes. We were running with at least 4 of the small nodes and sometimes 5, which was then for most of the environments the capacity limit. And so we said, okay, we will change it. We will switch to a 4 CPU and 16 gigabytes of RAM VM SKU, which is way better, and we can deal with it with around 2 nodes or 3 nodes. It depends. But this is much better now with bigger base nodes. Okay, pros and cons of the migration. So I try to summarize it a little bit in pros and cons. They are similar in amounts, but I think the pros are way outweighed the cons. So from now we have much more flexibility in all areas. We can do whatever we need inside the cluster. We can deploy it. We can manage it however we need. This is quite useful, especially we try to move everything inside the cluster that we can do that has no internal state. For example, the initialization or cleanup jobs, that is something we could, or that we did then with Kubernetes jobs. And now we can grow this application consistently without growing this app service environment more or less, which is, from my point of view, more consistent. And it's quite easily because we did it already a few times. On the con side, we have everything is do it on your own. You need quite some knowledge on Kubernetes and Azure to build such an environment, especially if you do some fancy stuff inside the cluster, and you need to do that on your own. You need to be aware that AKS applies node updates every night, but you are responsible for rebooting those nodes, or for example, use a node upgrade channel. But it's your job. That is something that we didn't have to do it with app service. But this is from the overall perspective doable, but you need to be aware of it. Another con for us was the low support for IDEs. So we are using Visual Studio to develop the application, and for one bounded context, for example, we need to start at least those 3 executables: command, query, and the protection handler. And to do that with containers inside the Kubernetes cluster is possible. There are projects like Project Tai that you can use for it, but it was not very convenient from the development flow. And so we said we will rely on the multi-startup project. In other projects, we use Docker Compose. But as of now, it's at least for the Visual Studio world, not so ideal. And that's why we are not using Kubernetes on each development PC to debug the application there. Okay, things I would do differently the next time. So I said a lot about how we did things, but what are the things that I would change? So from my opinion, it's very important that you consider security stuff as early as possible. Right after the migration, we could talk about things like, do we need read-only root file systems? What should we enable? What should we disable? And this is good if you do it early, because we made the experience, if you enable such a feature, you might not notice immediately what it does, or that it kills some functionality. So doing that early in the process is a good thing. The same applies, for example, to the standard policy setting inside the cluster. As soon as you have that in place, it's much easier to work against it than trying to fit everything afterwards to the policies that you applied. That's my experience. So I would say do that as early as possible, because some tasks we needed to do later, and that was, it needed a bit more effort than we would have done it earlier. Then, because we were using domain-driven design, I would go to the approach to say one bounded context should equal to one Helm chart. Right now, we use one Helm chart per component. But they share some of the functionality, so it would make sense to deploy one bounded context with one Helm chart, because right now we version them together, so it makes sense. We could then simplify as well the CI/CD setup. We would have one Helm upgrade instead of 3 or 4, and like the centralization of common resources like network policies that apply to the whole namespace is something that is more central and not just in one Helm chart. There would be an alternative like Helm file, but we said we won't use this tool as of now, because it's, I think on the project page, they say it's not officially on version 1, so there might be breaking changes, and the way that we implemented it with our push-based approach is fine for the moment. Another thing I would do differently is to split Helm charts and app source code into separate repositories. This is just, let's say, from the convenience perspective, you can manage them on a separate, more separate way. Let's say it like this: you don't have to deal with exclusions in your pipelines, which is easier to maintain. It works how we did it, but I think there's a bit of improvement there. Then I would split our basic cluster components pipeline from the infrastructure pipeline. So right now we need to wait until our ARM templates are finished before we deploy our cluster components. Sometimes, I don't know why, but sometimes ARM needs more time than it should need. And then we the pipeline needs like, I don't know, 10 minutes to deploy. Yeah, the last point is use GitOps. In this project, we used, as I said, a push-based approach from the pipeline to the cluster. That's totally fine. It works well. I think GitOps is a nice topic. If I would do it again, I would have a closer look at GitOps. We're using it in another project. It's a quite nice approach, but it depends a little bit on the team and how it should be then operated later on. So if the requirements are there and if the project allows to do it, I think it's a very nice approach. Okay, and then last but not least, things to keep in mind when migrating to Kubernetes. So I think you heard it throughout the presentation. When using Kubernetes, you need to have much more responsibilities than you have with an app service. So you need to be aware of them and you need to be able to deal with them. So this needs, of course, knowledge inside the team to know what it needs to do with AKS, for example, then upgrade AKS from time to time. This comes also to the components that you install inside the cluster, like the ingress controller, cert manager, QD. All those are compatible to a certain Kubernetes version, and you need to keep them in sync. And of course, you have to respond to vulnerabilities that occur in those tools, which is also something that you need to do. So yeah, you need to keep an eye on that. If you build such an environment from scratch, like we did, plan with some extra capacity for cluster management and networking tasks, especially if you didn't do it before or never had done it before. So you need to know what you should do with the networking. Do you want to have a cluster internal ingress control, or do you want to externalize it? Do you need to integrate with other services? Maybe do you have to go through a VPN? This is all things that you need to consider when designing your AKS environment, and the cluster management tasks, how you want to do the versioning. For example, we use auto upgrade channels for the patch version. As soon as it's a minor version, we check it if we can upgrade. Right now we run on 1.22. So I think it's the latest as of now available on AKS. But these are things that you need to deal with. Then, I mean, the infrastructure, to build the infrastructure is one part, but to use the infrastructure in a usable way or in an efficient way is the other part. So having such a flexible platform is one step, and then you need to have the teams, or you need to have the knowledge inside the teams to use the functionality. So for example, that they can use jobs inside Kubernetes as well, what they could do or should do inside of Kubernetes and what not. This is something that is good to have or makes your life easier with Kubernetes. And the last topic is just automate as much as possible. We did it. The whole environment is automated. So the creation, the upgrades, it's just a matter of a click if we need it. We, for example, migrated the development environment between tenants, and this was very fast. The most of the time, we had once one issue where we forgot to delete or to purge the key vault. So this was a timeout, but then it just ran through, and it was done in 2 hours, where we had most of the time wait for the timeout. And the other one was a Cosmos DB. Cosmos DB takes quite some time to deploy. So still automate it as much as possible. It helps in reproducing the stuff. And with that, I'm at the end of my presentation. As I said, I'm from T&M. We try to find good engineers that want to work on projects like the one that I presented. So if you're interested, you can contact us via our career site, or you can contact me as well. And with that, I'm at the end. And if there are questions, feel free to ask.
Thank you, Marc. That was really interesting. And I do have a question. And the question is, how did it look like in terms of cost, in terms of Azure consumption?
Yep.
I guess it was more expensive after the migration, but was it twice as expensive or more?
Well, it depends how we compare it. If we compare it with the isolated instances, then the isolated instances would be more expensive because if I have it right in my mind, it's 2 cores and 16 gigabytes of RAM cost 400 Swiss francs per month. I don't have it correct in my mind, but in the beginning, because we migrated from the public SKUs to AKS, it got a bit more expensive. Right now, we need around, with a standard environment, around 600 Swiss francs for the cluster. But if we would map, those are then 3 nodes with 4 CPUs and 16 gigabytes of RAM. And if we map it to an isolated instance, we are still cheaper than using isolated instances.
Okay, thank you.
So far, I don't see any questions in the chat. But if anyone has still listening and has one question, please feel free to write it in chat, and then we could tackle the questions in the last minutes. But in general, also from my side, for sure, thank you very much, Marc. This very interesting and valuable session from you. Okay, so yeah, I would say I don't see any questions until now. I don't have something on my own. Manu did it, and so there comes the thank you. Yeah, great. Nice to have you here, Sebak. So I would say last time, thank you very much, Marc, for the session, and have a good night and evening, everyone. And thanks you for joining our session, and hope to see you next time.
Bye-bye.
Ciao, ciao.